second part of the QAPP webinar. So Center for Watershed Protection, Lisa, Deb, and Chris, they're going to go over QAPP examples and guidance and dive a little bit deeper into the different examples of QAPPs. So if you're planning to apply for a LISCIF project, or you're currently working with one and you're affiliated with the LISCIF program, this is the webinar for you. If you're new to QAPPs and if there's any questions you have, you can hold them at the end and we can discuss them. And also after this meeting, if you think we should do additional trainings on specific areas of QAPPs, feel free to indicate that and we can always work together to put more webinars on. But without further ado, I'll pass it to Lisa and we can get started.
Great, thanks, Shahela. So today, well, last week on our first webinar, we talked about QAPP 101. So all the basics of QAPPs and the different sections and information that's included and when and why you need a QAPP. But today we're going to dive into some of the examples and guidance. So I think it'll be pretty fun today. We have some actual examples from approved QAPPs, and we're going to walk through some of the key sections that people kind of have a hard time with. So a little bit about today's webinar. We'll talk a little bit about what the webinar series is. We'll do a quick icebreaker and introductions. And then the main things we want to cover today is a template that we're developing for the LISCIF program. We wanted to share kind of preliminarily what we've been working on and get your feedback on what might be useful. And then we're going to talk through some primary, secondary, and modeling data, QAPP examples, and then also some additional resources. So first, a little bit about the Center for Watershed Protection. We are a national nonprofit that was founded in 1992, and our mission is to advance clean water resources and healthy ecosystems through responsible land and water management. So we have 4 main program areas. There's applied research, watershed and stormwater technical services, training, and we also have a membership program. And we're headquartered in Maryland, and we have about 24 staff right now. We do work across the country, and our staff are from Maryland, Virginia, Pennsylvania, New York, and South Carolina and Michigan. And so a little bit about the webinar series. Shahela, did you want to say any more about that or?
Yeah, so for those of you who are not familiar with the Long Island Sound Community Impact Fund, the purpose is to build capacity for the region. So especially with organizations who have never really received federal funds before or are new to the process of QAPPs, or they want to try to get the bigger grants that require them. This is just like kind of training purposes. And so one of the trainings came out of discussions within the region, and they said, hey, it would be really great to have like a QAPP 101 training, you know, for us to kind of prepare for these bigger grants, or if we wanted to get into these particular projects. And so we have like a set of curricula on our website where we cover different aspects of capacity building. And again, it's very adaptive. So depending on the needs of the region, we will continue to grow that. And so this is how it kind of came out for these webinars.
All right, and then just a quick introduction to our speakers today. Shahela, I think you introduced yourself. I don't know if you want to introduce yourself again.
Yeah, I don't remember if I did. So I'm the program director for the Long Island Sound Community Impact Fund, and we're in our second round of funding for 1.5 million. LOIs are due on November 22nd. So also on our website, you can see our current recipients and some of the projects that they're working on. But all of the projects focus on environmental justice within the Long Island Sound and the CCMP. Thanks, Lisa.
Yep. And I'm Lisa Farley McNeil. I'm a senior watershed and stormwater research specialist at the Center for Watershed Protection. I do a lot of work on like our research projects and watershed planning projects, and I'm also a GIS nerd. And so through the years, I've helped develop a lot of QAPPs, and I've helped others develop their own QAPPs. So our role really is to help other organizations or through the LISCIF grantees and RA program to develop QAPPs to help them get through the EPA review process a little bit quicker. And also just build capacity in general for being able to do the QAPPs. And Deb?
Yep, I'm Deb Caraco. I'm a water resource engineer with the Center for Watershed Protection. And have worked, for a long time there, do like watershed planning and, stormwater stuff. And I've kind of, I guess if I have a special role, it's kind of all things data and spreadsheets. And so, over the years I've written, a bunch of QAPPs, and I'm glad to be helping Lisa out with this project and helping other people do them.
Thanks, Deb. And Alexandria?
Yeah. Hi, everyone. I'm Alexandria. I work at the center as a watershed planner, and I've been at the Center for Watershed Protection for about 3 years. I've contributed to the development of QAPPs, and within the last year, I've waded into the QAPP review process as part of our work with LISCIF. And so my recent work working on developing the QAPP template for this project has served to highlight key areas that often challenge QAPP writers, and I'm determined to help provide assistance that makes the QAPP process more manageable for everyone. Yep. Thank you.
All right, so before we go around and do introductions for everyone that's on the call, we're going to do a poll question. Let me pull it up here. So if you were on our QAPP 101, this is a similar poll, I think it's the same poll question, but since we have some new folks, I thought it'd be good to just kind of get a better feel for what our experience is in our audience today. So have you never written a QAPP? Have you contributed to writing sections of a QAPP? Have you written a complete QAPP and experienced the review process? Can you write QAPPs in your sleep? Or what is this QAPP you were talking about? All right, I'm going to go ahead and close out the poll and share the results. So it looks like most folks have never written a QAPP. We have one person that's contributed to writing sections of a QAPP, and we have a couple of folks who are wondering what this QAPP is all about. So hopefully we'll help to answer that question today. All right, so what we're going to do is just go around. I thought it'd be good to learn who our audience is today and kind of hear what your experience is with QAPPs. So we'll go around. If you can share your name and where you're from, if you have any experience writing QAPPs you want to talk about, and if you're currently working on a QAPP, it would be really interesting to hear about, particularly like what types of data you're working with in your QAPP, because that's what we'll be talking about today. So like, are you collecting new data? Are you using existing data, like maybe doing a literature review, or are you doing any type of modeling work? So we'll just go around. You see this, Kevin, would you like to go first?
Yes. Hi. Good morning, everyone. My name is Kevin Barfield. I'm part of a group, Camden for Clean Air, that's based in Camden, New Jersey. I know nothing about this. I received this email. Just so happened last week, I was part of the Delaware Watershed Forum and did a presentation on our community group and how we actually got involved in this water area. Our base is more or less dealing with air quality. So, my past experience dealing with being part of NAACP, community activism and stuff, I kind of like been in a lot of different areas and spaces. So this is a new space for me. I'm gonna be a part of a group that's doing a coastal resilient project. So I'm kind of wanting to know more about watershed and kind of like what it should look like, and then even understanding like how and what does our watershed look like, because we have a river and a lake that's close to us. So I'm just kind of like learning all about this water space.
Thanks, Kevin.
Thanks.
Next we have Adam.
Hey everyone, I'm Adam Doan. I work with a consulting firm called SLR. I'm based out of the New Paltz office, which is New Paltz, New York in the Hudson Valley. I have no experience with a QAPP before the one I'm currently working on, which is part of a Long Island Sound Study funded project to look at flood mitigation solutions for along the east branch of Blind Brook in the village of Rybrook, New York. And we will be collecting ground-based survey data, some stream characterization data, aerial imagery, and then integrating that into hydraulic models to assess some feasible solutions to reducing flooding impacts through that village. But I'm excited to be here and appreciate the opportunity to learn. So thank you, everyone.
Sounds interesting. Next, Jesus.
Hey, good morning, everyone. My name is Jesus Sanchez. I'm based out of Cleveland, Ohio. I'm actually with Restore America's Estuaries. I'm the program director for the Great Lakes Environmental Justice Grant Program. So happy to be part of this team. I'm kind of learning in a lot of different ways today and being part of this session. One is I have no direct experience in terms of QAPPs, and aside from, data collection and water quality collection in my past experience, knowing that that's contributed to other grants and initiatives and studies that have gone on locally. And then the other aspect of this is just kind of learning, putting on a session, in terms of like capacity building and informing others who kind of very similar experience in terms of maybe not having that experience. So just happy to be part of the conversation and here today. So thank you.
Great. Chris. Oh, Chris might not be on. Samara. Okay.
Hi, good
Thank you.
morning. Hi, good morning, everyone. My name is Samara. I work at the New York State Department of Environmental Conservation. And I don't have any experience with QAPPs. I'm doing my first one right now, and it is related to a project we're working on in Westchester and which part of Westchester was that again? Well, it's on the Titus Mill Pond. If you are familiar with Westchester County, I'm not as much. But we're working with the regional staff that work in Westchester to complete a site survey of state-owned wetland and an ecological assessment. So we're trying to figure out like the state boundaries around this wetland in order to complete some restoration work on the wetland itself.
Great. Next we have Tim.
Hello, I'm Tim Macklin. I'm with Collective Oyster Recycling and Restoration, or CORE. I'm in Milford, Connecticut, and we run a statewide shell recycling program in Connecticut. And then that shell is used for oyster habitat restoration projects in Long Island Sound. And I did not make the first webinar, but I watched it last night. It was very informative. Thank you. But I'm still not 100% sure our organization needs a QAPP. So I'm hoping I come out of today with a clearer picture of whether or not we need one.
Yep,
So
sounds good. Next up, and I apologize, I'm probably going to mispronounce this. Is it Rania?
Hi, Rania. Got it on the first one. My name's Rania Campbell-Boussier. I'm a senior grant specialist at GZA Geoenvironmental. And I'm based in Portland, Maine, but I work with a lot of organizations in Connecticut. And I have not written a QAPP, but the like scientists and engineers on our team usually write those, but I'm excited to learn more to support that better.
Thanks. And Tay.
It's probably Ray. Sorry for the mistype. That's okay. Ray Hinkle with AKRF, and I'm working with Citizens United for the Morris River down southern New Jersey. They've got an RAE grant to control Phragmites in an area where we have populations of sensitive joint SED. growing and looking to prevent Phragmites from overtaking areas. So we have a QAPP requirement under RAE grant requirements, and we're going to be working towards completing that.
Yep, sounds good. Is there anybody I missed that would like to introduce themselves? I think I got everybody. Okay. Well, yeah, it was great hearing everybody's introductions. I think all the work you all are doing is really interesting. I think that's my favorite part of helping with the QAPPs is just, learning more about everybody's project and just seeing all the cool stuff that's going on. All right, so for our first part today, we're going to jump into a QAPP template that we're developing, and Alexandria is going to talk about that.
Yeah, so we're just going to walk through a couple of the features that the template will include, and please feel free to throw stuff in the chat, or there'll be time for questions and comments afterward, because we are open to all comments or things that you might find helpful for the template. So starting here, we have a screenshot. And so while this template is developed for LISCIF QAPP or like LISCIF grant recipients, hopefully it could be used by anyone, but certain things will need to be discarded. So we have things that are color coded. There's general information, supplemental information to assist users in completing each section of the QAPP. And so we have like gray color coding for general information that applies to everything and everyone who will be using the QAPP. And then there's like blue highlighted information for projects that are collecting primary data. And then yellow for projects that are using secondary or existing data, and pink for the projects that are using modeling. All right, so we can go to the next slide. All right, so each section of the QAPP includes a description and purpose, which provides a reason for why the section is included as part of the QAPP. Then there's outlined required content, which is information that has to absolutely be included in the section. We've also included tips and notes that highlight practical things to do or information to include in the section. For example, for project task description and schedule A5, as we have screenshotted here, there's a note about remembering to include time for QAPP preparation, review, and approval in the schedule. So it's something that could just be missed, or you're focused on other things while you're developing your QAPP, but like little things that need to still be included. And then also some content prompts, which are questions to ask yourself and your team about the project. And the hope is that these will help you include all the necessary information for your specific project in each section. Because sometimes the way the EPA describes things, you're like, huh, what? That doesn't make any sense. And here's just an example of like, when you're looking through the QAPP for each section, how things would show up for like considerations for primary data in this section versus considerations for existing and secondary data, and what you might include for modeling data. Right, next slide. And then finally, as you're working through the QAPP template, we have included example text or boilerplate language where possible. And that's to give the users a jumping off point to develop their QAPP, because staring at a blank page is excruciating. So I think it's pretty clear that QAPPs are not one size fits all. So like any language or text that's included in the template, it needs to be carefully read through and adjusted to match your specific project. And so there's one area highlighted in orange box, or inside of the orange box, which shows that like sections of text that are denoted by that square brackets, those are designed to be replaced with specific project information. And we tried to be as detailed and descriptive as possible for the type of information to include. All right, so that was like a real brief overview. Are there any thoughts or questions about the template that we have in progress? See some heads shaking.
Right here, just, the page that I've seen, with all signatures and the like on there, is there guidance, with regard to who all needs to sign off on the document?
Yes, there is. I didn't show a screenshot of like the signature page, but there are certain titles within the QAPP that can be kind of confusing as to who exactly that's supposed to be, sort of like the operations manager. But we did include definitions for those titles and suggestions for who on the project or within your organization might be able to sign those.
Yeah, thanks.
Mhm.
I think one thing we were trying to do with this was to create like one document so that you could use, so you wouldn't have to like flip back and forth between like a guidance document and a template. And there's a lot of content in there Alexandra's been working on. So we've kind of been going back and forth of, is it easier for folks to have just the one document, have like all of this content in there, or would you rather have kind of like a separate, more blank template that you fill out with like a program guide on the side that you're kind of like a companion guide that you're reading through and being like, oh, this applies to me. Let me put that, in this section. I don't know if anybody has a preference for that. The main thing being that we have this really long document with all the instructions and it's a template, but when you get to the end of now you've completed the template, you still have to go back and kind of delete the sections that are like instruction information in order to polish it up.
I appreciate you all doing this because even with the guidance from Region 1, although there's a lot of guidance that I'm thankful for, it is really hard to navigate everything. So this is really helpful to kind of guide folks along within the template, like what you have to do step by step. So I appreciate you all working on this.
Yep, thanks, Shayla. All right, well, we're going to continue to refine that template and then, yeah, we'll share it with everyone. Or Shayla, I'm not sure if, it's going to be widely distributed or if it's just for LISCIF, but
Yeah, it can be widely distributed. If you guys are all signed up to the LISCIF newsletter, we'll probably put a word in there when it's ready. And it'll also be on the website as well under resources.
yep, sounds good. Okay, well, we're going to dive into the next part of today's webinar, which is walking through the specific examples. And so we're going to start with primary data collection, and then Alexandria is going to talk about secondary data collection, and then Deb's going to talk about modeling. And so with these examples, we're not going to go through all the sections of the QAPP because we don't have time, but we're going to focus in on some of the key sections of the QAPP that tend to be stumbling blocks. And so I'm hoping with these examples, it'll give you a better idea of the type of information that should go into that section. So for primary data, just a reminder of what this means. This is any new data that's observed, collected, stored, or generated directly for a specific purpose. And so this is like if you're going out doing monitoring data, collecting monitoring data, sampling and analysis, you're doing any direct measurement of environmental conditions, if you're doing any water or other environmental media monitoring, and it's important to note that this also includes like your volunteer monitoring efforts. So if they're collecting information that's going to inform a decision later on, that's still considered primary data. Any type of data that's collected or analyzed to support decision making, which also includes site assessment prioritization. Also, any data collection and analysis with the development or design of plans and projects. So this is like if you have a restoration project and maybe you're collecting some sort of information or doing some sort of monitoring that will inform that project design. So then that would require QAPP for primary data collection. And so our example today is going to be for an oyster reef restoration. And so with this project, it was found that the success of oyster reef habitat is limited in some locations, and it's suspected that there are environmental factors that are kind of limiting oyster growth and reproduction. And so the goal of this project was to strengthen the restoration project site selection by quantifying seasonal and spatial trends in oyster larva settlement and determining the influence of local environmental conditions. So basically they're going out and collecting oyster spat or doing oyster spat monitoring, and also collecting water quality data, which is water depth, salinity, pH, temperature, dissolved oxygen. And they're looking to see if there's any correlation between the water quality and the oyster spat that they're monitoring. So one of the sections that tend to be a little bit tricky is this data quality objectives and performance acceptance criteria. So like if you're looking at the QAPP standard, this is section A6. And the official definition of what data quality objectives are is that they clarify the study objectives, define the appropriate type of data, specify tolerable levels of potential decision errors. And basically all that means is you're coming up with an overall qualitative or quantitative statement that says, what are the data needs and how good do the data need to be to support the project objectives? And so we have a few statements here, and I'm going to read through them, and I want you to be thinking about which one of these do you think is an appropriate overall data quality objective statement. So the first one is to follow all procedures outlined in the QAPP for collecting oyster spat and water quality. The second is to determine limitations to success of future oyster restoration efforts. The third is to collect oyster spat and water quality data capable of quantifying seasonal and spatial trends in oyster larva sediment to identify limitations to restoration success. And the fourth is to restore oyster reef habitat. So of those four, which one do you think is an appropriate data quality objective statement? You can either unmute yourself and just shout it out, or you can put it in the chat box.
3.
3.
3. Good. Good. Everybody's got it. It's relatively specific. It talks about what are the type of data that you need to collect, you know, why are you collecting them, and how good do they need to be? Here we go. And so for the next part of this section, deals with data quality indicators. So you've started out with your data quality objective, which is kind of like a more larger overarching statement. And then the indicators get down more into the detail. So this is how you're going to measure the quality of the data and determine if you have enough data to meet your project objectives. And this is done through a series of elements. They call it the Parks parameters. And we're going to walk through each of those. So the first one is precision. And so that's a measure of the repeatability of the measurement. And so some examples here, you know, they're going to have different people going out and they're going to be counting the oyster spat. And so having a difference of less than 10% in the spat counts between the people that are counting the spat would be an example of an indicator. Another indicator would be differences less than the following for repeat measurements. And there's just a series of like less than 0.3 milligrams per liter in dissolved oxygen difference between the repeat samples, or less than 0.2 in pH between samples, etc. The next parameter is accuracy or bias. And so this is the agreement with a known value. And so the indicator that they used for this one was that all calibrations for their equipment would be within acceptable limits. The next parameter is representativeness. And so this is the ability to represent a population. And so the example indicator for this is that they were choosing monitoring sites that would be representative of various conditions which could impact their restoration success. Sorry about that. Comparability is the ability to blend data from multiple data sets. And so they're going to be following consistent sampling methods used by oyster monitoring groups. And they're also going to do consistent sampling and processing methods across each site and sampling month. So they can compare between sites and seasons. Completeness is just talking about the amount of data collected as a percentage of the data that's needed. So they're going to collect 80% of water quality samples and 100% of the oyster spat counted on the individual shells that they're collecting. And then finally, sensitivity is the ability to differentiate between different levels of a measured variable. So for example, these are the different ranges in the water quality parameters that they're going to be measuring. So like 0 to 40 degrees Celsius for temperature, 0 to 20 milligrams per liter for dissolved oxygen. For oyster spat, they're going to be measuring them down to 1 millimeter or less. And now we're going to move into the next section that tends to be a little bit of a hang up. This is section B in the QAPP. And so this is the identification of project environmental information operations. And so this is where you outline like what is your sample design and what's the rationale for that sample design. And there's a few kind of key components that should be included in this section that we'll walk through. So the first one is just laying out where are your sampling locations and what is your study area. So for this example, there were going to be 15 monitoring sites that represent a broad range of conditions. They also provided a map and had locations for each of their monitoring sites. Another thing that you'll want to talk about in this section is what is the specific media that you're sampling. So in this case, they're collecting oyster shells, water quality data, and they're also collecting air sample, or not collecting air samples, but they're taking temperature of the air. You want to talk about the number and types of samples that are collected. So in this case, they're going to be doing monthly water quality and oyster spat monitoring for 1 year. They're going to take one sample at each site for each of the water quality parameters that they're measuring. They're collecting 10 oyster shells for spat counts at each site. And they are collecting, their sample sizes are consistent with other established oyster monitoring programs. And so I think the key thing that a lot of people miss in this section is it's not just outlining, you know, your sample design and what you're doing, but it's also providing the background information of, well, how did you land on doing that sample design? Or why did you select, or why did you decide on this? I think in most cases, you know, people are following like standard operating procedures or methods that have been done in the past. And so it's always good to reference those if you're using them. And then also sample depths are good to include. So in this case, they're taking water temperature and water quality samples 20 centimeters above the sediment surface. And then they're also measuring water depth from the sediment surface to the water line and total depth of the spat collection device to the water line. And then also, if you're doing any field and lab parameters, specifying which of your parameters you're taking in the field and which ones are going to be done in the lab. So for example, in the field, they're collecting temperature, water depth, dissolved oxygen. In the lab, they're doing pH and they're doing like their spat counts in the lab. And then we're going to move into section B2. So this is the methods for environmental information acquisition. And so while B1 that we just talked about kind of lays out the overall sampling design and strategy, this section kind of moves into the details about how you're specifically taking that sample. Like what are the actual methods for collecting a sample or making a measurement? So some examples of what to include in this section deal with sample collection. So this talks about how they're going to record their water temperature to the nearest whole degree, how they're going to lower their dissolved oxygen sonde into the water to take a measurement, what types of sample bottles they're using and how they're putting the sample bottle into the water to actually take the water quality sample. And then also how they have these oyster sampling devices that they've secured down to the sediment. And so how they're going to actually take those sampling devices out and take the oysters out and then randomly select the oysters. Also important for this section is like your sample handling and chain of custody. So for example, for the water samples, they're going to be how they're going to be labeled and recorded on a data sheet. How the oyster shell sample collection bags are going to be labeled, and then they're going to be placed in a cooler with no ice. What happens when you get back to the lab? So in this case, the shell samples are going to be placed in the refrigerator until the oyster spat counts are done. Water samples are going to be sampled for pH and salinity. So the time frame for doing that, they'll all have to be done within 24 hours. And then the spat counts will be done no more than 30 days after field collection. And then specifically, if you have any lab methods, oh, sorry about that. If you have any lab methods, you'll want to list them here. So like they're doing pH, so they're talking about what the specific equipment is that they're using and methods. And then the standard oyster monitoring SOPs that they're going to follow, they put in appendix. And then finally, we're getting into the last section that kind of causes people some trouble. This is the section D or D2, which is the usability determination. And so with this section, it applies to the point of the project where you've gone out and collected all your data, and now you're analyzing your data and looking back at how it relates to your project objectives. So how are you going to use the outputs of the data review to determine if you've actually collected the right type of data, the quality of the data that you need, and the quantity of data to support the intended use? And so for this example, some of the things that they were doing were scatter plots and value ranges that they were going to review for anomalies. And then if they had any unexplained anomalies, they were going to discuss them with other lead scientists on other monitoring projects. They're going to look at any data limitations they're going to consider when using data to guide future oyster reef restoration. They're going to look at spatial and seasonal trends and monthly spat counts to predict where and when oyster restoration projects are most likely to recruit oysters and create habitat. And then the water quality metrics collected are going to provide context for the trends in oyster settlement beyond seasonality and help inform site selection parameters. And so I think these are all good. There's a lot of general statements about what they're doing. One thing that could be done if you were looking to improve the section a little bit more is get into some of the details about how this is going to be done. So if they're doing any type of like statistical analysis to relate the water quality sample data that they're collecting to their spat counts, that would be good to describe here. And how they're going to determine whether that data makes sense and they can use it, or if it doesn't make sense, then what does that mean for the project? Can they still use it somehow? Do they have to throw it out? That would be the type of things to discuss in this section. And I just gave you the answer to that, so sorry. I walked through a lot with this, so are there any questions? Okay, if there's no questions, we'll move on to the next section. This is for the secondary data. And Alexandria, do you want to take that over?
All right. Go to the next slide. So talking about existing and secondary data, quick definition is that this is data that has been previously collected, derived, stored, or reported in the past or by other parties. And that's for a different purpose and or using different methods and quality criteria than the current project. Sometimes this is also referred to as data from other sources. And these secondary data or existing data includes existing sampling and analytical data from a previous investigation conducted by your organization most likely, or from different studies or organizations. Could be computer model simulations and applications pertaining to other studies. Could be historical GIS data, data generated to verify innovative technologies and methods. Could also be publications, photographs, topographical maps, meteorological data, environmental indicator data, or literature files or searches. So this commonly comes into play for like for watershed plans. You'll be collecting a lot of historical GIS data or even sampling data for water quality that has previously been collected, and also for literature reviews. All right, next slide. Okay, so the example project that we'll be walking through for secondary data collection is going to be a project for innovative stormwater remediation. And so for this project, nutrient pollution is one of America's most widespread, costly, and challenging environmental problems, and it's caused by excess nitrogen and phosphorus in the water. So the goal of this project is to implement demonstration projects and test the nutrient removal effectiveness of an innovative method of nutrient reduction at multiple projects across the region. And so the first task of this project is to complete a literature review of high quality experimental and observation studies. So part of their literature review includes existing sampling and analytical data from previous studies, publications, literature files, and searches. And additionally, they use existing and secondary data as part of their project site identification, which includes historical data and case studies. So we're going to take a look at their DQOs for the literature review. So as Lisa previously explained, the data quality objectives are qualitative and quantitative statements that describe what the data needs are and how good the data needs to be to support the project objectives. And so here we have some examples for this innovative stormwater bioremediation project. And so I'm going to read through these, and then I want you all to tell me which one you think is the appropriate DQO for the project. So one is to ensure that site selection and assessments are conducted using accurate and precise information that satisfy project criteria. 2, to determine the potential of the innovative method to reduce nutrient reduction. 3, to collect secondary data that is relevant to the project goal, representative and salient to the region under study, and accurate. Or lastly, 4, to determine if a document is appropriate and how much influence each document should have on the final recommendations. So once again, feel free to unmute yourself and say which one you think it might be. Throw it in the chat. I'll give you guys like a couple seconds. I'm suggesting 3. Other thoughts? I see some thinking faces. All right. Shaking heads. It's okay. This one is actually challenging. I tried not to make it tricky, but and Shahela, you're not wrong. 3 could be a correct DQO for this project because it is detailed and it outlines what the secondary data would be used for. Like what data is needed and how good it needs to be to a certain extent. For this specific project example, number one was actually the DQO they used. And if you notice, it's vague sort of, and it's because it's the overall DQO for the entire project. And there are other aspects of the project that include the collection of primary data as well as secondary data. And so part of that QAPP was they had that kind of vague overall DQO, and then they also had more in-depth DQOs. But ideally, you would want to create like high quality DQOs for both your primary and secondary data as like overall statements for each. Are there any questions about all of that? All right, we'll move to the next slide. All right, here we're going to be discussing example of acceptance criteria for the literature review associated with our innovative stormwater bioremediation project example. And so there are 3 acceptance criteria that they used. The first is relevance to the study. And so this is what makes the data relevant to their project and purposes. So, which is whether the data collected supports their project goal of reducing nutrient input from stormwater based on the innovative methodology used. And that was what they outlined as their description for that acceptance criteria. Next, there was that the data was representative of the areas and times of the study. So that answers the question of how is the data representative of their project and purposes. In this case, it was about the area and location on the Gulf Coast, and that may include existing data on general overarching principles that are salient to their project purpose. And then they also provide a time frame for the data that they'll be collecting, which was both current and long-term data, or recent and long-term. And then lastly, their criteria also included examining the existing data collected for anomalous values and outliers as well. All right, next slide. Now we're on to DQIs, so these indicators that they used. And I want to clarify that this is slightly different from the DQIs that are set up and organized for primary data in that they follow the parks elements, and that's not necessary when working with existing and/or secondary data. Instead, the EPA guidance suggests like general assessment factors, which are based on soundness, applicability and utility, clarity and completeness, uncertainty and variability, evaluation and review. And we're not going to walk through all of those. We're going to walk through the example ones that were used for this project. So first up, their first DQI, an example indicator, the element was year, which is representative of the time of the project, which aligns with their acceptance criteria. And so for high quality existing and secondary data, they categorize that as data that was published in or after 2000 or any seminal research. And what they considered low quality was the documents or research that was published prior to 2000. Go to the next one. All right, next was applicability, and this is relevance to the project goals. So high quality data for this was something that matched the purpose or scope of the existing data and the information that they needed. And then low quality was something that doesn't apply to the project goals or information needed. Next up was study location, which is representative of the target project area. And so they were focused on the Gulf states or the Gulf Coast region, and there were specific states that they outlined on their project. And then low quality was anything outside of the larger regional Gulf Coast area. So like something in Oregon was not going to be applicable. All right, then there's data collection and analysis methods. So this is the soundness of the methods used to generate the existing data. And their high quality data was determined as approved state or federal methods used, statistically relevant analyses, versus low quality, which would have methods that weren't documented or insufficient data was collected. Then moving on to conclusions, which was defined as like the degree of clarity and completeness of the conclusions pulled from the data. So for them, high quality data was where the scientific method was evident. The conclusions were supported by statistical analysis. And then low quality was inconclusive conclusions and insufficient evidence for any conclusions that were made. And then the last one was looking at the references, which was the extent of independent verification, validation, and peer review. And so high quality was the majority was peer reviewed, and low quality was minimal to no peer review for the data or documents that were collected. Okay. And then next up, we're moving on to the usability determination. And so from this example, what they used for their usability determination was that the data was going to be examined for anomalous values, and they were going to reject values that were reported well beyond the range of observed variability, as well as identifying any gaps in the data and identifying like the lack of studies or where studies and theories seem to disagree. And the number of exclusions, the source of the data excluded, and the suspected cause of error or rationale for exclusion was going to be documented and included in final reports. So those are the couple items they use for their usability determination. Does anyone have any thoughts on how you might improve these? Quick hint is that Lisa still gave you the answer when she discussed primary data. So some suggested improvements would be to like relate these statements back to specific project objectives, and also including how they'll know that they met their goal and emphasizing the purpose of the secondary data. Okay. Once again, that was a lot of information, but does anyone have any questions or comments? Is anyone currently working on any projects with existing secondary data? See shaking heads. All right, then I suppose we can move right along.
Oh, thanks, Alexandria. So I am going to be talking about modeling data, and I have to say, I thought, oh, well, you know, I bet we're not going to have a lot of people who are doing models. And then I think it was Adam said, I'm doing a QAPP about modeling. So yeah, we'll see how this, what do you think? Thanks so much. You could go ahead. So modeling is, it's a little different than the other two. I guess they're all different from each other, but the modeling is somewhat different in that we're we're making or using a predictive system to represent the environment. So we're not, we're not doing a library search, or we're not, at least the modeling part, we are not actually collecting data. It's the model, it's the data that we're generating. The other thing is that models can be kind of anything. Kevin, I was going to put air quality models as an example of something that can be, can be one of the kind of models you can do. But they can model, we talked a little about, they can model, how much flow there is. They can model how much, annual pollutant loads there are. That's a lot of what we see. They can be looking at in-stream water quality. They can be, models that are looking at, very kind of complicated models that kind of look at how different biology performs, or, things that happen within the system. And then things like, a lot of times people use these little calculators that say, oh, I did this practice, how much benefit am I going to get? We end up operating almost entirely in this using existing models area, like at Center for Watershed Protection. And I think a lot of the work that you all do, there's kind of a whole aspect of modeling, which is, developing a new model somehow. Like that can be an equation or a process. And I think there's even another category about using a model to compare different things. But so there's, they could be almost anything. Could you go next one, please, Lisa? Okay. And so that they can model almost anything. And the other things about models is they can, again, I kind of talked about this, but I really can't emphasize enough. People get really intimidated sometimes by modeling QAPPs because there's so much stuff you're supposed to be doing if you look at the whole thing, but models really and the modeling QAPPs can really vary from really, really simple things up to very complicated. So, some kind of model and kind of just general characterizations. Really simple models will tell you something. It's like either an annual average of something or just one number. They might need one or two inputs, or, just a handful of things that you have readily available. The biggest thing, and again, like to just emphasize, is they don't need to have a process of being kind of calibrated somehow. We're going to adjust them to make them match up with other data, or they don't need a lot of, other analyses to make sure they're working right, essentially. So we kind of operate mostly, and again, I think most people will be working there. And then there's these kind of middle range ones that maybe they'll give you monthly values. They might need a little bit of tweaking to make sure they're working right. We'll compare them to something that we know. They might be using literature values so for models, like a lot of the QAPP is about like what information are you putting into this model. They'll use, literature values, or they might have, some numbers already that are there as a default. And then another thing, again, like not so much to talk about all these different terminologies, but like I feel like people get very turned around by it. They could be something that is called a statistical model that'll just be basically, we have some equations that kind of characterize how this thing works. Like, so a statistical model would be basically, we think the load from this land use is 5 pounds per acre. And, we're going to, assign that load. Or it could be something that's a physically based one, which is, I think, how a lot of people think of models, which is trying to redo or kind of show how things physically happen. They're kind of, it's going to say, oh, there's evaporation, and then some of the water goes into the land. And then we really very, very rarely are looking at kind of the most complicated models. For people who, kind of are in this world a little bit, like swim is really pretty complicated, but, there's also like, estuary models, like all these very things, complicated things. They'll usually give you data that's on a really small time step. Like, so you might be able to get hourly data as your output, and you'll often need a lot of really detailed hourly data or any of this as the input. There's also there's usually a lot of different information to put into those kind of models and a lot of knobs to turn. So a lot of what the QAPPs need to be for these much more complicated ones are like, how are you going to turn these different knobs to make sure that this model is working properly? So there's going to be a calibration where you kind of adjust it and get the knobs working right. Then there's going to be a verification where you say, okay, now does it, I'm going to compare it again. These are, again, typically they need additional data to help develop it, and they're often, in that category where they're trying to basically do a little model of exactly how the world works. Could you go to the next one, please? Thanks. Okay, so we're going to do an example that's from really something that's in that like very simple to almost a little bit to the medium level, but it's a pretty simple type of model. So we only have to really look at a couple of the steps that, or not every single modeling step that you might need to do. So the example is a small urban watershed that drains to a larger estuary that is impacted by nitrogen pollution. So in this watershed plan, the purpose is to identify restoration opportunities to reduce the loads from urban runoff and land-based sources of pollution, and use modeling data to quantify watershed loads of nitrogen. Okay, so the modeling activities are going to be to estimate nitrogen loads and then estimate the pollutant and actually nitrogen load reduction from the restoration activities that we're going to propose. So those things on the list are riparian buffer restoration, stormwater retrofit stream restoration, and some municipal operations like street sweeping and catch basin cleaning. Could you go to the next one, please? Okay. So kind of this will look familiar from the other two. So this is the data quality objectives. What are the data needs and how good to the data need to support the project objectives? And sometimes for modeling, the questions also, how good does the model need to be? You know, the model that I selected, how good does it have to be? So what would be a good example of a good DQO statement for the watershed planning example? One would be identify high quality and cost-effective projects. The modeling effort needs to produce graphs of change over time, complete modeling of sufficient quality to estimate average annual pollutant loading from a baseline at a fine enough detail to document 10% pollutant load reduction from identified projects, or 4, identify the, involve the public in the planning process. Any ideas? All right. Yeah, we have some 3s. I think your answer was could be 3 too, Alexandra. And I don't know if you used 3, so that might have been a giveaway. But yeah, the key here is it's detailed. It tells you what the goal is for the modeling, and yeah, and we're relating it. It's great if the objectives can be numeric. No. Thanks. Okay. So I'm going to talk a little bit about the data quality indicators. So there's a big kind of caveat to the modeling that I'm going to mention this here, but it's kind of like for overall. So in this presentation, I'm trying to kind of talk about models in the QAPP framework and template. That's the new framework. And we have not seen modeling data using this new framework yet. So I'm taking, many states have a kind of modeling QAPP guidance that's based on old guidance, but it's a little different setup. So I'm trying to kind of fit that into here. So if you're doing modeling, first step is talk to your state to make sure they don't want you to use the old modeling template if they have one. But anyway, that's kind of just a general. The data quality indicators, again, I'm using this like slightly different than the parks. It's a little bit mixed. So the soundness, the other thing too is here for the data quality indicators, I'm specifically talking about model selection and performance. So for soundness, I guess kind of what would that look like? It's, so soundness is like, are the methods reasonable for what you're trying to do for the intended application? So it's kind of like a, general, like, does this seem like, is it the right choice? So we want to model what this QAPP said is the model uses standard methods for estimating pollutant loads. with which uses coefficients and assumptions that are similar to other models. The model has been used by other watershed planners in the region. So it's kind of like a general, like, does it seem, seems kind of like I'm on the right track. Could you do the next one, please? Applicability and utility. So this would be the extent to which the information is relevant for the intended use. So in this watershed plan, we're trying to estimate loads of nitrogen, and we're trying to estimate certain kinds of BMPs. So is it an applicable model? We need one that gives us annual loads of nitrogen from small watersheds. One that seems like it's not going to be a big issue, but is often a problem is not a lot of models are able to reflect all the different kinds of BMPs. So one of the applicability checkboxes is capable of modeling urban BMPs included in the watershed plan. And the third one is the land uses in the watershed are consistent with those identified in the model. There's lots of models that are only good for urban areas or only good for rural areas. Next one, please. Clarity and completeness. This is really a typical one. In general, anything EPA related, if you're using a model, they want you to use one that has a documentation of all of what its assumptions are. That's kind of generally that's true, but just making sure. Last one. Evaluation and review. So this is always a question you're going to get if you're trying to use a model. Is it peer reviewed somehow? Or in this case, it says like, is it recommended? Does your state agency that you're working for have a list of models that you can use, and it's one of them? And I think I did one more. Yeah, so accurate and precision. So this one's more, it's kind of crossing over, that we want one that it's going to be within 25% of estimates from literature for loading rates. And it estimates to about the nearest pound per year of nitrogen. Next one, please. Okay. Did this not? Okay. Oh, all right. Sorry. Yeah, the animation wasn't perfect. So I'm sorry. Actually, this B2 on this it is identified properly. This is actually the it's the methods of collecting data is the category this should be called. This is kind of is going through basically how are you selecting the kind of data that you're going to put into the model, and how are you going to use it. So in this case, we have what kind of model are you selecting? This is often a little bit of an issue where you kind of want to say, this is why I'm selecting the model that I'm going to in the QAPP. And then you're going to say, but I am selecting this one and how I'm going to use it. So in this case, we used one called the watershed treatment model, or the QAPP used one called the watershed treatment model. That's selected based on the DQO criteria. And how is it going to be used? The kind of standard model the kind of like standard methods that are identified in the model are going to be used. We're going to use efficiencies and pollutant concentrations that are made primarily the model defaults. So it's kind of just saying we're going to use it and we're not going to really override very much. Primary data. So this is one thing about a model QAPP is that you kind of have what you're doing with a model, but then you also, sometimes you're using other data. You're using other primary data, or you're generally using other primary data or secondary data. The primary data in this case is the field techniques. So we're going to do these different BMPs, but in order to propose them, we were going to go out in the field and identify the operations. So, that primary data, is going to be, used to populate the model. So how is it going to be used? We're going to show how big the projects are, the extent of the projects are, what's their drainage area, estimate site level impervious cover. So we're going to be looking at, on site to estimate how much impervious cover there is, what's the condition of our stream and how much restoration opportunities there could be, and look for opportunities to create stream buffers so that, the data, those are the kind of data that's going to be come from the field studies. Secondary data. So again, this is back to Alexandria's section. Her example was literature data. Secondary data can also be like mapping or weather data, any of this kind of information. So in this project, the secondary data that was used in the model was county GIS data. We used some census data and weather data. And what did that tell us? The GIS data told us what our land use was in the watershed and what the land cover was. Told us about the soil groups and the watershed population and our annual rainfall. And we did have also secondary data from the literature, which helped us with a little bit tweaking this model to see what our pollutant efficiencies are and any land-based loading rates. So looking in literature to see what was the, how many pounds per acre for urban land in this area. And that was used to check or modify our model results, and it was later used in model calibration. Next, please. Okay. And again, this is a B2. Just a little bit of a diving in. We also, so in this section, you can say, okay, we're going to use this data, describe how it's going to be used in the model, but we also want to flesh out the details of that. So for example, one of the things we're doing with land cover data in this project is, we're using it to populate the model, and we're going to estimate the impervious cover in each kind of land use based on land cover. So in this QAPP, it's going to lay out, it used, it's going to describe how, we're going to describe how we used default concentrations, how we describe, characterized land uses, and how we adjusted the land cover data. And that's kind of this section. There was a little bit of an adjustment to this model that said that, the model might just say residential. But we're going to tweak that so that it reflects what residential land looks like in this watershed. That would need to be laid out in your QAPP. So, you'd show the equation for how you do that. We would also describe with our field data the details of, not just we're going to do this assessment and it's going to go on the model, but, we're going to do an assessment, and in the model, we're going to put, the drainage area to that practice. We're going to put how big the practice is going to be. We're going to put, those details. So it really, is telling you each step. Next, please. Okay. All right. So for the thing that's a little different about the model in QAPPs is that the data review portion. So in our QAPPs, it's like, the last part is kind of where we're reviewing the data. We're seeing, is it good enough? We're, adjusting things. For a lot of modeling operations, there's a lot of work happening here, especially if it's a very complicated model. In this case, it was pretty simple. But so we talk about like, what's our process for adjusting our input values. So we kind of really, lay that out. Say, okay, we're going to start with our model defaults. We're not going to have in-stream data that's gonna, allow us to tweak the model bit by bit. So we're going to, use our literature-based values to estimate our typical loads. Then we're going to check to see, based on our literature values, is our model within about 25% of that? And if not, then, maybe there's something wrong with the model. Maybe there's something wrong with the literature values. If they're different, we're going to adjust the model assumptions, and see like, maybe one of our concentrations is just, not where we think it should be. Or if we can explain the difference, for example, maybe the land in this, maybe residential land in this area is really impervious, or maybe for some reason we just have high nitrogen loads, then we can kind of stick with our value. But we want to just, use that as a check. Could you go to the next one, please? Okay. So there's a couple questions here. This is pretty simple, like we think of modeling as being pretty complicated. And, for lots of models, there's lots and lots of steps and interconnectedness. I guess one question I have is, why do we think it's so simple in this one? And if we were doing a really, really complicated model, what would be some other things that we might be doing? I don't know if we have anybody I don't know if we have any modelers here. So some of the biggest, anybody? Okay, I don't. So if we're using a very complicated model, and if likely, so some of you may be, involved in doing models, or, I think maybe more likely, just based on a lot of the organizations that you all are with, you may be, subcontracting with somebody who's doing modeling. The biggest pieces is going to be about this, like calibrating your model in this up. So this section, this last hurrah for the data that's in QAPPs, usually you're just like, oh, I'm going to check it and see if it's okay. Here, there's a lot of, okay, well, if it wasn't, if it's not quite matching the data, I'm going to separate some of my data together, and I'm going to look at it, and I'm going to start adjusting it. And then I'm going to take some of my data I'm comparing to, and I'm going to run it again and see, does it match that data? So there's kind of a lot of pieces that when you're doing much more complicated modeling, there's tons of steps. And when you're doing really simple modeling, you may need to not do very much, at all. This one's kind of had a little bit, but just kind of, again, I think the main thing with this is not getting kind of overwhelmed by what more complicated models have to do when, again, we might be just dealing with some pretty simple ones. Next, please. Are there any questions about modeling?
Thanks, Ed. I had a question, yeah. Regarding your clarity and completeness slide and what you should actually include, whether through appendix or otherwise. So what I'm thinking is, like, with nationally recognized model platforms or programs, like the current HEC-RAS manual is like over 800 pages. So do they actually want that appended to it? Or can you provide a link to the existing or current version?
You can always provide a link, and,
okay.
and that's actually for this applies all across, for all, I guess maybe, I don't know, maybe for the secondary data, but for the primary data, this is, if you're all involved in those, it's the same situation, like, lab SOPs, like, or methods that you might use. Like, you don't need to like append to your QAPP like pages and pages of how the lab accepts their reagents. And just like the same thing, you don't need to append a whole HECRAS manual. But sometimes different reviewers, another thing about QAPPs is different reviewers are different from each other overall. And so sometimes you might get, you might have an issue where you have to have in your QAPP kind of a justifying a particular input to the model, even if that's part of the manual. But no, absolutely, I wouldn't append it, just do a link. Yeah. Any
Thanks.
other questions?
I have a question.
Yeah.
So you mentioned about, if I'm correct, you saying about the air quality part.
Yeah. Yeah.
And you talked about excluding that. Can you talk about, the reasoning why you exclude it? And I think, part of it, does it make it more, complex? To actually use air
So
quality data?
So yeah, it's always more complicated to lose more. So I'm sorry, when I said I excluded it, I just meant when I was, when I had the list in the beginning of what I was talking about of different types of models, I meant to list air quality and didn't list it. And then I said, man, there's an air quality person here. So, as far as though you're asking though, like, we didn't have an air quality model in this water quality model. Is that what you were asking about?
No, well, I was saying, while you saying not having it, I didn't know if that was, you not having it, a part of it, is it a reason why? Because like you're saying, the simplicity, or, you can have your models extreme and things of that nature. Is that one of the reasons why, it's not mentioned in the project, because it can make the project more, complex, trying to gather, air quality
gather
data?
all that data. Yeah. And so I think it would be, so if we were doing a watershed project, there are models that try to incorporate air data, and they are generally more complicated. That's true. And in this project, we used one that, honestly, it doesn't really incorporate us collecting water quality data either. It's a really, really simple one. But yeah, the most complicated, I would say overall, the most complicated models of a watershed would include both air and water. But again, there's air models that are, you know this better than I do. I'm sure, like there's stuff about, there's air quality models that aren't even connected to water modeling. They're just about your health. But yeah, the most complicated ones will try to show all the different pieces, including air. Yeah.
Thanks.
Sure.
Okay, we're getting really close to 11:30, so I want to go ahead and start to wrap up here a little bit. So we went through a lot of information today. So I wanted to share with you just some resources that will help you with your QAPPs. So EPA resources, there's a QAPP development tool website, which is really helpful. It will walk you through the different steps of developing a QAPP and has a lot of good information. And if you were on the last webinar, we talked about the new QAPP standard that came out. I think it was August of last year. So there's a link here to that QAPP standard if you wanted to take a look at it. The new QAPP standard comes from EPA headquarters, but the way it gets implemented is through the different EPA regions. And so each EPA region is kind of rolling out some of their resources in different levels. And so we found Region 1 has some pretty good resources out. I think some of the other regions are still in development of their own resources and actually how they're implementing the new QAPP standard. But this link here is for Region 1. They have a program guide, they have a template to use, a checklist. This is all very helpful, and a lot of times we refer back to this just because it's easy to understand. And then also another resource is the Center for Watershed Protection. We provide support for QAPP development, and specifically through the LISCIF grantee program, we're developing the QAPP template that Alexandria shared. And so we're not trying to reinvent the wheel for something like what Region 1 did since they already have their own template, but we're trying to take the template and just make it a little bit more applicable to the LISCIF grantees and make it a little bit easier to understand, but also provide examples like the things you saw here today and all like boilerplate language, things that you can pick from just to make developing your QAPP a little bit easier. So that will be coming soon, so stay tuned. And then I just want to thank everyone for joining in. I hope this was helpful to you. We will have, or Shahela will have the recording and the slides posted on the LISCIF website. And if you have a minute or two, I think there's like a 2 or 3 question survey that'll pop up after the Zoom webinar just to ask if, you still have any questions about QAPPs or if you have any interest in future trainings, what the topics might be. So Shahela, do you have any final words?
Yeah, thank you so much for CWP, for Lisa, Alexandra, Deb, and Chris. Again, as Lisa mentioned, it'll all be uploaded in the link that I put in the chat. And if you need any other support, if you'd like to go deeper into some of these QAPPs, if you think additional webinars might be helpful, or any other capacity building support you need in the region, feel free to reach out. My email is in the chat, and we can talk more. But thank you so much for CWP for just breaking down this complex process and making it a bit more digestible for folks who are doing this for the first time. And thank you for joining us, everyone.
Thank you.
Thanks, everyone.
Thanks, Al. It's great. Appreciate it.
Appreciate it.
Thank you.
Thank you.